Hello, welcome to section 7.1. So in this example, we're going to determine the values for which a rational expression is undefined. So a rational expression is a fraction, right, that has like a polynomial in the numerator and a polynomial in the denominator. I'll just call them P and Q. So because it's a fraction, it has a denominator, then you can't have division by zero. So if you're dividing by zero, that's undefined. So in order to figure out where the rational expression is undefined, you want to figure out where the denominator is equal to zero. So those values are problematic. Those values are where this fraction is undefined because you're dividing by zero. Okay, so let's look at these parts. So for part A, we have 8a squared b over 3c. So you're trying to figure out when the denominator is equal to zero. So you basically make it equal to zero and solve. So 3c equals 0, this gives me c equals 0. So this is where this rational expression is undefined. So undefined when c equals 0. So the numerator doesn't matter. You can have the numerator equal to 0 because in a fraction, 0 divided by something is just 0. But a number divided by 0 is not defined. So you're trying to identify those values where you're going to have a problem. Right? B, we have 4b minus 3 over 2b plus 5. So you're going to take the denominator, 2b plus 5, and make an equation out of it equal to 0, and solve. Subtract 5 from both sides. 2b equals negative 5, so b equals negative 5 over 2. Right, so this is where this rational expression is undefined, right? If I plugged in b equals negative 5 over 2, I'm going to get a number on top divided by 0. So it's like, can't do that. C, we have x plus 4 divided by x squared plus 5x plus 6. So we're going to take this, make it equal to 0. Right? And because this is a quadratic, to solve this equation equal to 0, we factor. So we have x plus 6, x plus 1. And this gives me x equals negative 6 and x equals negative 1. So those are where the expression is undefined. Right, so there are two values where there's a problem. Okay, so if you go back to here, you can see, right, if I plug in negative 6, so at x equals negative 6, I'm going to have negative 6 plus 4, which is negative 2. And then over negative 6 squared plus 5 times negative 6 plus 6, which is negative 2 over 36 minus 30. Oh, I factored incorrectly. It's always good to check, isn't it? It factors as 2 and 3. Plus 2 plus 3. That's good. Why is that not equal to 0? What's going on? So it's negative 2 and negative 3. That's better. Alright, so let's backtrack a bit. Alright, so let's plug in x equals negative 2. So we have negative 2 plus 4 gives me positive 2. Then negative 2 squared, 5 times negative 2 plus 6. We get 2. 4 minus 10 plus 6. This gives me 2 over 0. Okay, so that's why this is on the list. Negative 2 makes it undefined because you're dividing by 0. Alright, let's check negative 3. Okay, so this tells me negative 3 is a problem also. So if I plug in x equals negative 3, again, negative 3 plus 1 is 1. Negative 3 squared plus 5 times negative 3 plus 6. 1 over 9 minus 15 plus 6 is 1 over 0. So that also makes division by 0. Right? So these, and with this sort of procedure, right, you take the denominator, you set it equal to 0, and you solve, you find all the values where it's undefined. So all the other values of x are fine. If you plug in any other value of x besides negative 2 and negative 3, then you're going to just get a number. But if you plug in negative 2 and negative 3, it's undefined because you're dividing by 0. As we're working through these problems, especially when we come to the section where we solve equations, we're going to come back to this because we need to check to see whether our solution makes sense, whether it's defined or not.